Just like any other data analytical software, or maybe more even, R is a package that requires that we all practice very often in order to ensure that whatsoever we learn is well taken and at the same time well internalized. And so I want to encourage us that as we are taking the classes, just like we are taking the one for today, at the end of each of the classes, we are expected to ensure that we lay our hands on as many activities as possible, apart from even the activities that are given as assignments, in order for us to be able to have some level of feedback as to how well or otherwise we are doing. Beyond that, we are also expected to do rigorous activities. Except that is done, I want to believe that it will be difficult for us to be able to call ourselves master at the end of the day. So, and I think I also need to pass this across. We were given some tasks to do. I just checked now and I discovered that the number that turned in the assignment that we were given last week is quite very small, and I don't think that is very, very encouraging. I hope our organizers will address that maybe later today, if time will permit, or next week, so that every one of us will be on our toes and ensure that we do not just come to take the classes, but that we are as active as is expected of us. Yeah. Once again, thank you very much, Dr. Elami, and thank you everyone that made it to the class as early as we were expected. And apologies for taking so much time last week. Today we are going to ensure that we do less of talking. We just go straight to the business, and we ensure that as much as possible we are able to finish within time. Okay, so I think we should just start by reminding ourselves of what we did last week. Okay. Yes, we read some comments that suggested that the classes were not as interactive as we expected. Yeah, just few persons anyways. So I want to start on that note. It would be nice to have one or two persons possibly give us a recap and also give us an idea of what he or she did after the class, what went well, what did not go well, how were you able to address the different point in time when you possibly ran into roadblocks trying to do some stuffs on our. So I want one or two persons to signify so that we can just call us, and yeah, thank you. Do we have anybody that wants to give us a recap of what we did last week? Okay, Kafila Todeshola, I want to believe you started talking already, so you can go on.
Oh, I think I was on speaker anyway. My mom was asking if I was going to respond. So I was waiting for somebody to talk, and before I know if I want to go ahead. Okay. Well, last week we talked about wrangling, as in being able to have data, and then you want to have an idea of the let's call it editing that you want to do now. You want to be able to edit appropriately so that when you take the data to R, you'll be able to have good data to analyze, so there will not be any hindrances. And in getting that done, some of the software that needed to be downloaded includes DeepR, if I can pronounce them well, which is usually involved in as a visual aspect of it with regards to the GG+2, when you want to visualize to have an idea of if there are outliers or there are things you need to take care of in the process of cleaning the data for further analysis. Then you went on to talk about other what will I call it now? Other editing, I'll call them editing, other cleaning methods that one can actually do. Take care of if there are duplications and other editing factors, so that at the end of the day, we'll be able to have a clean data that will be well analyzed. And for me, when I got to the assignment part of the work, there were things I was not too clear with. So I had to go back to your lessons and then look at them, use them as a basis to answer some of them, and that brought about a better understanding of what we were taught. Initially, I thought with me having the classes, since I was in the class throughout, I'll be able to answer them, but I got stuck at the time. I had to go back to the video and start using the video to answer those questions, and with that, I was able to understand some other aspects that didn't really go down well the last time you had the class.
Oh, okay. That was a very good one. Well detailed. Thank you very much. I think PiLAF, thank you for also turning in your assignment. So you were one of that submitted the assignment. That was a very good one. Thank you. Okay, one more person,
Yes,
please.
Hello, sir.
Okay, Modupe Susawo. Yes, you can
Hello,
go ahead.
sir.
Yes, you are on.
Yes, sir. This is Abidini Bashir for Lanshaw.
Okay,
So
okay.
last week we talked about data wrangling, and we talked about data cleaning to be a portion of data wrangling. So we used the data from R, which was called Star Wars. So in order to do the data wrangling, we had to download the package called tidyverse, which comprises of dplyr, ggplot2, and table, in order to be able to do our data cleaning. So that was what was done, what was used to clean the data. And later we needed starter to be able to do the other part, which was the finding the outlier to inserize our data for the data cleaning. And after the class, then I had to see the video again. So I did the assignment. Actually, I had 9/10.
Wow.
So and
That's a good one.
I did some hands-on for myself on the Star Wars in order to clean the data, since we were taught how to clean data. But after, when I was doing my assignment, I had some challenges. I saw that I was not able to replace the NA in the list, because the data Star Wars has it has the list, character, and integer to be the types of data that is in Star Wars. So the NA in the list, I was not able to correct that, but I was able to correct the integers and the characters with the method we were taught. So when I wanted to correct the character, I had to enter the code one by one, like to replace the NA in the character with none. But I was thinking if there is a way, because for the integers, you give us a code to use to replace all the integers. So I replaced it with character. I don't know if you remember, we had a code to replace all the integers with the main.
Yeah.
The main. I was trying to do the code to replace all the character with none. So I was not able to do that. So I had to enter the code one by one to do it one by one. But at the end, I was able to clean the data, but I was not able to work on the list. But at least I have a clean data on both the integer and the character side. So I think I have that. So I was able to clean it from the NA to none, and I think I have a clean data with me on Star Wars.
Okay. Yeah. I think. Let me just speak to that. It's not actually in all cases that you want to replace your missing data with either none or even main in the case of continuous variables. It's not in all cases. As a matter of fact, it's expected that, yeah, to a reasonable extent, if the data is well entered, just omit your NAs for that variable. Okay.
Yeah. And I also find out that
because you remember. Hello, please. Can I? Okay. I can hear you. Yeah.
Yeah, I found out that instead of using none, I can actually use another word, like for the sex. Actually, not, I didn't use none. I actually put in, maybe, okay, replace all, instead of none, I put male and replace everything with male. So I used something else for gender, like masculine, replace all the none with masculine, and it did masculine. For the color, I put, okay, replace it with black. It's with black instead of putting none for everything.
Yeah. Okay. Yeah, that's good. Yeah. Let me also say this, that yes, just like I said, that it's not in all cases that you are supposed to be expected to replace your NAs with a particular information. As a rule of thumb, once you have missing items, especially for data that you did not collect, let's say data you accessed maybe on the World Bank data repository or something, you do not want to just replace missing items with just anything. So just go ahead and use na.rm to remove the NAs for that column, so that you can just go ahead with your other activities on the data. So, but in some cases whereby you understand, maybe you were the one that entered the data, or you have an idea of what the things you go into that particular data, then you can think about the particular information that you want to supply. You also remember that I said that there are different data scenarios that requires what step you are required to take, what action you are required to take. But I just gave those options as possible options for data cleaning, as the case may be. But it's not like a rule of thumb that you must either replace with main or you must replace with some specific values. For those data sets that you have gotten from credible sources like the World Bank, you may just want to do your NA.rm and go ahead with your data processing activities. Yeah. Sorry, the time will not permit to take so much time. We have 21 minutes spent already. I think we just go straight to the business of today, so we do not waste so much time. Anybody who has any question can email me personally. I think I had a chatting time with someone today, although we've not been able to resolve the issue, which is basically around installing. I think one of the packages was not installing, and there are some complaints on how. So I think if you have any issue that you feel we need to respond to, kindly feel free to either to chat us up, and let's see how we may help each other in that regard. Yeah, thank you very much. Yeah, we are still continuing with data wrangling. Today we are looking at module 2B. We are looking at module 2B, still data wrangling, and basically we'll be looking at introduction to the dplyr package. We talked about this just like we did introduce. What we did last week is like a continuation. I mean, what we are doing today is a continuation of what we did last week. So I'll just briefly introduce dplyr package. Many of the things I'll be talking about today were already said last week, so I'll just briefly go through them. Then selecting variables of interest, which is what dplyr would help us achieve. Filtering rows, we talked about this. We mentioned this in passing last week. We are going to talk about it today, and we are going to see some script that will help us to filter rows based on certain criteria, based on the particular information that is of interest to the study. Now, we're also going to look at how we can group data by categorical variables. We have different types of variables. In this case, you want to group your data by a particular categorical variable. For example, sex. If you have a data set that has male and female, and you are interested in splitting your data set by sex, you want to have male results for male separately from your results for female. So we're going to look at group data by categorical variables, and how possibly we can generate output even from this categorization. We're also going to look at how we can arrange variables by values. This is also what dplyr will do. Then how we can create new variables. Last week, I also mentioned something around this, particularly when I was talking about mutate function on how. So those are the things we'll be looking at today. Last week, like some of us reminded us, we dwelt so much looking at data cleaning. Of course, we have been reminded so sufficiently about that. Okay, then today, yes, we also talked about indexing. I think we did that also in passing. I'll be talking about that briefly today. Then we'll be summarizing based on some qualitative attributes. And of course, last week we did pipe operator. We're not going to do that again today. So now, basically, I'll go to the script, to the latter part of the script that we did last week, to discuss indexing and subsetting. Then, summarizing data. I will just quickly go into that, then we'll go into the business of the day today. So what's indexing? Yeah, when you index, what you are doing is to just select the data that you need for a particular circumstance. Okay, and even though it's possible to index a vector, you could also index a matrix. Prof talked about matrix the other time. The difference between matrix and a data frame is the fact that for matrix, we are talking about the same types of variables. Okay, but for data frame, we are talking about different types of variables. So for a data frame, you can have characters, you can have numeric variables, you can have integers, you can have factors, as the case may be. But for matrix, you have the same type of variables, across board. So that's just the difference between a data frame and a matrix. So, but basically, because most of the time you'll be dealing with data frame, I think we'll concentrate more on data frame today. When you subset, what you are basically doing is you assess some elements from a particular object. For example, a data frame that you have created, let's say a data frame containing about 10 rows and maybe about 100 cases. So you want to select maybe just 2 out of the 10 columns, rather 10 columns and maybe 100 cases. You want to select just 2 columns, okay, which is talking about 2 variables belonging to, say, 100 persons. I mean, collected from about 100 persons. And so that's subsetting. You want to subset a certain portion of that variable. You may also want to subset those columns on the basis of a particular criteria, in which case we are not even talking about all the cases, all the 100 cases. We are also selecting maybe 40 or maybe just a number that possibly meet a particular criteria that you would have preset. So that's subsetting. It takes out a portion from the object based on the condition provided. Okay, so let me just take us through that part. Yeah, to indexing a data frame. I want to believe we can all see. Okay, there is a data frame, a data set in R. Okay, which is called iris. Okay, that's iris. Yeah, last week you want to have an idea of what you have on iris. To say, you say glimpse iris. Okay, you have an idea of yes, what you have on iris. So you have about 150 rows and 5 cases: sepal length, sepal width, petal length, petal width, and species. Those are the variables you have in that data set. Okay, you have about, yeah. Okay, so in order to pick the first row of that variable, okay, third column that contains the value 1.4. Okay, you are doing this. You are doing this. When you have this is your data frame. That's iris. You can see that here, this line of code is saying that iris should be referred to as iris df. And so once you run it, subsequently it recognizes iris as an object within this script. And so you are now saying that in iris, I'm interested in when you have these square brackets. What you are trying to do is you are trying to index. Okay, and you are saying you are interested in row number 1 and column 3. Row number 1 and column 3 of this data frame. Okay, it gives you this. So that means that's the value in that, in that position. So what you have done is to have indexed this 1.4 based on the information that you are supplied to have. And that's why what you have here. In the case of this next code, what this is saying is you have this square and you have a comma. Immediately, once you open the bracket, okay, you have this comma, but nothing is written here, unlike what you have here where you have 1. Nothing is written here. What you are saying is you are not specifying any particular row. You are interested in all the rows. Okay, but you are now interested in column 4 to 5. When you have this column, okay, it means 2. So what you are saying is you want all the rows, but only column 1 to 5. So you run. Only column 4 to 5. That's column 4 and 5. And so you run. So it has given you that. Okay. Then you have, of course, we can also make it an object, but that is not necessary. If that is what you are interested in as a study, okay, as a data set to use for your analysis, you can just use it to create an object, and subsequently you continue to do business with that as an object. But in this case, it's not necessary. This is just to give us an idea of how you can actually index or even subset your data, so a portion of your data set for any further action on that data. So you have, hello?
Sam, your comments for that action is not clear. When you say pick up the first row, the third column, it's understandable. This other part of that contains the value 1.4. What is that trying to say?
Okay.
And it's for the 2. So I'm thinking maybe there's a mistake somewhere, especially for the second one.
There's no mistake anywhere. Just please listen. What I said was inside this iris data frame, you are picking the first number here. Just after you open your square bracket, the first number here talks about the row number. And so you have this as your row number. You are interested in row number 1 and column number 3. Okay. And so that will give you only one figure. If you look at head, okay, iris, your head will give you 46 entries. first 6 cases with alongside all the variables. So you have this. So look at this. This is your row number 1. Okay, 1, 2, 3. This is your column number 3. So this is the number that we have indexed out of of that data set. Do you get it? So that is exactly what this code is talking about. Okay, but when you look at this is different, is a completely different command from the first one. This one says all the rows, but only column 4 to 5. All the rows. That's why you have this command here. You are not specifying any row. If you select,
sorry, the comment in that position is saying pick up the first whole. I think that's where the problem. First whole, not all the whole.
Comment is
comment.
Okay. Sorry. I think I must have made a mistake somewhere. Yes. Pick up all the rows. All the rows. Hey, there's a problem. Yeah. Okay. Then column 3. 4 to 5. Yeah. Thank you very much. So that's what that is talking about. Thank you. Okay. Now, when you look at iris, this line of code, iris species. This is indexing species that is located in this data frame. This species here, anytime you have this $sign here, you are talking about a column, a particular variable within this particular data set. So in this case, this is your data set, this is your data frame, and you have species located inside that data frame. So when you run it, okay, so it has given you the species, all the species inside that data set. Okay, and so look at this, iris df square bracket iris df $sign species. What this is saying is that you are interested in only setosa within this data set. You are interested in only this setosa within this data set. And so by the time you run it, okay, and if you look at this column, this comma is saying that you are interested in all the columns. And that's why it's giving you all the column within that data set, but it's giving you only for setosa. You remember that under species, we have more than just setosa. If you look at this earlier output that we generated here, we have setosa, we have versicolor, we have, I think by the time you look at how many we have, okay, you understand that we have more than just setosa. But this is giving you setosa because we have asked us to give you only for setosa, all the values. Okay, but on the column for species, you are interested in only setosa, and that is exactly what R has given you. Okay, now for this line of code, what you are interested in is you are interested in setosa. Okay, but unlike here that you have indicated that you are interested in all the columns, you have indicated here that you want R to include only separ length as an additional column to species that contains only setosa. And that's exactly what this line of code is trying to achieve. And so by the time you run it, you discover that if you come with only separ length as an additional column to setosa. Okay, so it's giving you so it's giving you in this form, it's giving you separ width for setosa, separ width for setosa. And so there is no point bringing it out in the form in which it has brought the earlier one out. Okay, for this iris df, the same way, the same thing, but here you are interested in separ width and separ length instead of just separ width. But when you are interested in in more than one variable, that means you have to concatenate, and that's why we are putting this C here, meaning that you are concatenate separ width and separ length. And so you run. When you run, it brings separ width and separ length. Okay, separ width and separ length for setosa. Separ width and separ length for setosa. And so if, for example, you are interested in, okay, let's say a particular data set has sex, has age, and has and has maybe performance in the particular examination, and you're interested, and maybe some other variables, and you're interested in, okay, the age and the performance of just female. Okay, you can apply a code like this, in which case you are just saying, okay, the data set, and here it will be sex, and you are interested in here in just female, and for your column you are concatenate age and performance. So what R will just do is it will just go into that data set. Let's say the data set says survey 1. Okay, so it will just go into survey 1, and instead of bringing in all the variables as entered into that variable, into that data set, it will bring in just data information for your female and the variables that you have also commanded out to bring out in this function, that I mean in this code that you have written here. And so that is that about that. Okay, any question? Please, we need to run fast. Yeah, for this.
Sorry, sir, I didn't get this one, please.
This last one. This one, right?
I mean the one on conditionals. Yes, sir.
Okay, this one. Or this one.
The conditionals on the index retrieve setosa.
Okay, I've not even come to that. Okay, what you are doing here is
I mean it's the one above where you wrote subsetting in R. There are different
this
ways.
One. This place.
Okay.
This place, right? Can you hear me, please? Hello, can you hear me?
Yes, sir.
Okay, are you talking about this line?
Yes, sir. I can hear you, sir.
Oh, you have not answered my question. Are you talking about this? The one where?
Hello, sir. I think he's talking about line 203.
No,
line 203.
I'm not talking about the one you highlighted.
Okay, which line are you talking about, please?
Yes, 202 and 203, sir.
Okay, this 203 is not even an executable line, given that you have this hashtag here. But I'm just coming to 203 now. Okay.
Oh, sorry.
So here you use more conditionals on index, retrieve setosa and Virginia in the same column. So beyond just retrieving only one of this, only one category of the species that we have, you can come up with more than one. Here we have only retrieved only one, but here we are talking about, we are looking at the possibility of bringing out more than one. And so here you first of all do for setosa. This line here means or in R, so you do the same thing for Virginia, and after that you concatenate the columns. You say concatenate this separate length and separate width and separate length. So what you have done here is, even though R will, okay, you are indicating her here, but what you are simply telling R is to do the two together and bring out the two together from that data set. And so in what you are going to generate now, we now bring you setosa, Virginia, and alongside that, it will bring out these two columns that you have. And so let's see how that works. Let's say here iris set page. Okay. I'm trying to create that as an object now. So you run it. Once you run it, it will bring it out now. You run it. So what you have here is not only for Virginia, for setosa, for setosa, but it's also for both setosa and for Virginia. Okay, for both setosa and for Virginia. So that's what you have here. You can also do like this. View. Okay. So you have for the two. Meanwhile, instead of you can say here species, for you to be able to include your species in the data frame that you are generating. Yeah. Okay, something strong here. Okay. I think that has been taken care of. species, sepal length, species. Okay, I think it's capital uppercase. So what you have here give you both setosa and Virginica instead of what you have that does not have this column, specifying which ones belong to either setosa or Virginica. So, okay, I think we should continue. Yeah, how do we subset in R? What we've done, some part of what we have done also goes beyond just indexing into also subsetting. But I think specifically here, what we want to do now is how exactly do we subset? And so let's go to this data frame, empty card that's also in R. Okay, if you print your empty card, you have this. Okay, these are the variables. If you want to understand what empty cast is about, you could query R, you could question R that want to read about empty cast. It will give you further information about empty cast. It's trying to load, but that's not what we are interested in. So empty cast. So inside empty cast, you are interested in subsetting HP. You are interested in subsetting only HP. Oh, sorry, it's still loading. You can see this here. Something is going on. Okay, while that is ongoing, do we have anybody who has any question? Trying to rush now. The time is running so fast. Okay, so anybody, any question from anyone? So far, are we following, please? Are we following?
I'm following. So
Yes, sir.
Oh, okay. Oh, okay, that's great. So in empty
Yes,
cast,
sir.
we have
Following.
been okay, thank you very much. We've been able to index HP. So, and that's what you have here. So you are,
Yes, sir, we are following. We are following.
yeah, thank you. You are empty cast, and you are saying inside empty cast, you are interested in HP. And so that is exactly what that's giving you. For this, first 10 cars and remove columns 1 and 2. You are doing first 10, and that's why, yes, just like I said the other time, when you have this square bracket, and what comes in first is the row. The row, you specify which row exactly are you interested in bringing out. Okay, here you have specified that you are interested in first 10. That's, I mean, when you have it here, I mean, as it goes down, the cases here is equal to cars, the different types of cars. Okay, and so you are interested in the first 10, 1 to 10. I said this column means 2, but you're also interested in removing only, so if you have, for example, you have up to 20 columns, but you're interested in 18, you do not want to say concatenate C1, 2, 3, 4 to 18. You just want to look at, okay, all the 18, I mean, all the 20 columns, and the 2 columns that you are not interested in, you just remove it. And that's exactly what this code has done. So that at the end of the day, what you have left will be the entire data set, only that, okay, the entire data set containing cases 1 to 10, in which columns 1 and 2, only column 1 and 2 are dropped. So if you have 20 columns, only these 2 columns will be dropped as a result of this. And so the code is minus C. You are saying minus these columns that are concatenated here. And so at the end of the day, you have other columns except column 1 and 2. Other columns except column 1 and 2. Yeah, this is also subsetting. Here we are still continuing with subsetting. Yeah, you are interested in subsetting this. You have displacement, I think this displacement, okay, greater for cases of displacement greater than 60, you subset it out. Okay, and you are selecting HP. Even if you do not put this concatenation symbol here, it will still run because it's just 1. Okay, so if you run, and so you are saying empty cast, what you now have at the end of the day is empty cast for only cases that are greater than 160. And you are interested in only this column. Okay, so when you run that, you can see. You can see. Okay. Well, you may also be interested in, yeah, those bringing into that data set, okay, displaying in the new data set, so to speak, the column for DISP. So you can bring in your concatenation DISP, comma. Okay. I think should run. Yes, should run. Okay. Okay, it's not run. It didn't run. What's happening? Okay. Hello? Somebody wants to say something?
Yes, sir. Hello?
Hello, yeah, I can hear you.
Okay, sir. That line 203, where line 206, that's subsecting using 160. What do you? I don't get what you meant by empty cars that is more than 160. Is it with respect to with respect to DSP, variable DSP?
Exactly.
Okay.
But, okay. DSP is a column, is a variable. So you are interested in R coming up with a data frame, okay, that has empty, that is taking, okay, that has only DSP that are greater than 160.
Okay.
But you are not also interested in all the variables. You are interested in just some specific variables. So in this case, you have only picked HP. You can pick more than HP. Okay, for example, you can pick even WT.
Okay.
WT to run. What's happening? Okay. But it ran now. What's the problem? You say,
So I think, I don't know, it's, you are using the same name for a data frame for a data set, because empty cars is already a data set that has been loaded. Wouldn't that cause a problem?
sorry, what are you saying?
I'm saying that empty cars is like a data set that has been loaded, yes. And now you also named it. So wouldn't that cause a problem?
No, it will not cause any problem. You could overwrite anytime. You could update and overwrite. So you, for example.
But sir, from my own side here, it's running. It ran from my side now. It ran.
Yeah, I think there's a problem somewhere. I think I've experienced this on a number of occasions on this system. I don't know what the problem is. Okay, I think it ran now. So, but if we put in another variable, it's supposed to also run.
Yes. It ran from my side with another variable WT. It ran.
Okay, WT, right? Let me see.
Yes.
It should run. Yeah, it ran. But it's not bringing in that WT. Did you just bring in WT?
Yes, it does.
So sorry, that's a very big problem from my end. I hope this does not continue. Thank you for bailing me out. I think we should go on. Please try and run it also from your side. If it runs, then we are good, please. Okay. Now at this point we need to summarize. I mean, we're going to summarize in data set. So we have this data set on here that I think we have used so far. Iris, you need to library your tidy fast. Then you summarize. You name your Iris DF. Okay. Then you summarize. When you summarize, okay, you want to generate main, for example. This helps you to generate main. What you are doing here is you are saying you need to summarize a particular variable in your DF, which is your data frame here. And what is that variable? That's separ length. And so you are saying R should summarize separ length that is located in your DF. And so, okay. So what you have here is the mean for your separ length that is located in your DF. Okay, you can also create mean and standard deviation of separ length instead of just mean alone. And so this is the code here. You have your DF2. Okay, so instead of you are including standard deviation here, and you are saying SD is equal to SD. This SD is a function, and you are saying R should generate the standard deviation for separ length that is also located inside your DF. Okay, let's continue. this you want to summarize by group. You want to summarize by a categorical variable. Okay, yeah, like I said the other time, it's possible you have a particular data set and you have some categorical variables within that data set. For example, you can have a particular data set and you have as a variable male and female. And so you want to you do not want to summarize by the entire data set. You want to summarize by that grouping. And so you say, okay, you are interested in getting the main for group A, which is male, and getting also the main for group B, which is female. And so this is the code. You are saying summarize group by DF species. Okay, in this case, we are not using gender. So we are using species. Species is our categorical variable here. And you are saying main is equal to main. And main here is a function, just like SD here is a function. And so you run. So you say, okay, so you have that species for Setosa, the main for Setosa, and the standard deviation for Setosa as well. So, I mean, for all these species here. Or you can do it using, you can do a pipe operator, in which case you are telling R to locate DF, then group by species, then summarize. It's the same thing. And you are now naming it, you are giving the object this particular name, DF4. And so when you do that, it runs. Okay. DF4. It's the same. Okay. If you do not want to name as an object here, okay, you could say your pipe operator here, M, M, then few DF. Okay, so you start from here. Yeah. No. Okay, your DF group by species, summarize main, this. Oh, okay. So you're not supposed to put this. So you run. So you have this. Okay, so let's continue. We're almost done. Okay, so you have also this summarizing. Yeah, you sum. Yeah, this is you generate the sum. Okay, for this, for each of the species. So that is the sum for for each of the species of the three species that you have. So at the end of the day, you have the summation for each of the species and the standard deviation. Here you are generating the minimum and maximum of sepal length. Okay, minimum and maximum of sepal length, also by species. Okay. Okay, so this is minimum, maximum, also by species. Don't worry, this part that we are doing is actually one of the parts we're also expected to do today. So it doesn't matter the fact that I'm taking it out. I'm taking it out from the script for last week. What we did last week and what we are doing today are more or less the same thing. Okay, so it doesn't really matter. It doesn't matter. So here, what you have done here, what you are doing here is to just count. You are counting by species, and so you are saying group by species, summarize. Okay, but what kind of summary are you generating? You are generating by n. You are generating your n. That's the number in each of the species, and you are saying R should arrange by sepal length. Okay, so you have that means in the data set you have 50 for Setosa, 50 for versicolor, and 50 for Phryginica. Okay, the last code here, I guess, is the one that is helping you to identify the first and the last value. The first and the last value. If you're interested in the first value and the last value in your data frame, in the particular variable of interest. So in this case, we are talking about sepal length. So the first value for Setosa is this, and the last is this. For versicolor, the first is this, and the last is this. For Phryginica, the first is this, and the last is this. Take note of the fact that the first does not necessarily mean, does not necessarily mean the same thing as the minimum. Neither is the last necessarily talking about the maximum. So it depends on which one comes first as an entry for each of the categories that we're talking about. Yeah. So that's about that. I think I've been able to do justice to summarizing data, indexing, and also subsetting data. Yes, more importantly is the need for us to, when we get home, to go through this code again. They are not difficult, and I want to believe that it's just a matter of us going through it again just once, or everything will be clear. And I want to believe we will not have any issue. The codes are well written, and I think the explanations also are well written as well. So thank you very much. I think we should just go straight to the code for the day, which is a continuation of this exercise, where we're going to specifically talk about some basic functions that dplyr does. Some basic functions that dplyr does. So I think we should just go straight. I've introduced dplyr to us, and basically I said that dplyr is a package that you use to manage your data, to do all manner of activities that are required for you to be able to manipulate your data in a way that gives you a data set that you could say is good for you. I mean, it's good enough for you to achieve a particular objective in your data analysis. And so that is dplyr, and it helps you to do some basic activities. For example, it helps you to select your variables. It helps you to filter. It helps you to group your variables by categorical variables. It also helps you to arrange your variables by values, and also in creating new variables. We are going to be discussing that. Okay, so it helps you to mutate. It helps you to select as well. It helps you to filter. Okay, it helps you to summarize. That is, it helps you to reduce multiple values down to a single summary. It also helps you to arrange. Okay, that is, it helps you to change the ordering of the rows. It helps you to change the ordering of the rows based on the value that a particular variable, I mean, based on the values that you have on a particular column. So it helps you to arrange based on the particular the values that a particular variable has. So then the easiest way for you to get your dplyr installed is by installing your tidyverse, or you can also install your dplyr directly without necessarily having to go through tidyverse. Like I said last week, once you install your tidyverse, other packages come alongside it. I mentioned many of them alongside it. I mean, one of those packages is the dplyr. Or if you want to you don't want to do any business with other packages that tidyverse comes with, you may just go directly to install your dplyr. And so let's go straight to business. Yeah, beyond those functions, tidyverse also helps you to achieve quite a number of other functions that I will just run through for us to see for now. And I also expect that when we get to, we also go through them. So like I said, your library, and we have the data set that we are making use of. That's the mslib that I think we made use of it last week as well. You're having a glimpse of that variable. Okay, I took us through this last week. Okay, so these are the names, and these are the types of variables that you have. I mean, what you have here is indicative of the class, the type of variable that each of these are. So you have this from here to here as character, and from here to here you have them as continuous. I think I mentioned that last week. So you could have a glimpse like I did already. So if you want to rename a variable, okay, all you just need to do is you pick mslib and you rename. Okay, how do you rename? You rename from one name to another. You rename from one name to another. So you pick this and you say mslib, pick mslib, then rename. You rename whatsoever you have here is the new name that you want to give, and whatsoever you have at the end of this equals to sign is the old name. And so you are asking R to rename this conservation inside the mslib, to rename it as this. And so you are now asking R to show you whether or not, you want to have a glimpse so that you see whether that command is effective. And so if you have something like this, okay, you have something like this. So, and if you look at it, you discover that your conservation has changed to conserve. If you want to see what I'm talking about, okay. Okay, it will not run. Sorry, it will not run that way. Let's have a glimpse here. Conservation. You see conservation here. Then you are saying conservation here should be replaced with conserve, and so you run. Okay, so your conservation has changed to conserve. Okay. You can also save it. You can save it as an object. Okay. When you want to save it as an object, you do not need to put this pipe operator. I do not want to include glimpse. So you just remove that and you put the name that you want, the name of the object, the name you want to give that new object. You put it there and you run the command. Okay. Any question? Somebody there? So you run, it runs. And so you call your MC, it gives you, yeah, then you have your here as your new name, newly named variable. Okay, please.
Sorry, sir, I have a question. Yeah. Okay, I saw that with the second code, the variable names were in column and were in inverted commas.
Okay.
And from the first part, you don't have to inverted commas. Yeah.
Okay, this inverted commas.
Yeah. Where is the first one? Where is the second?
I don't think the inverted comma will mean anything. Yeah, it will not mean anything in this case. There are some cases that the inverted comma will mean so much. Okay, I think inverted comma means something. I think inverted comma means something. You have to put the inverted comma. Yeah. That's the code. That's the code. That's the code. You have to put the inverted comma here. Anytime you are renaming, you have to put in the inverted comma to indicate the name of the new and the old. Yeah, the inverted comma means.
Okay, but what I'm saying is that in the first code we run, there's no inverted comma in the names of the variables. Yes, where you are right now.
Okay, I'm coming.
And that it worked.
Yeah. I'm even having issues now. What I ran now, that ran so well, on again. I don't know what happened.
Yeah, that's because you've already changed it to conservation. You have to change it back.
Huh?
I think it's because the old was
okay, I should come from here. No, that's not because that's not it.
So I think it's because you overwrote the data set using the data frame and they share the same name.
Exactly. Okay. Don't worry, I'm sleep. Okay. I'm sleep. Let me say data. I think that's the thing. It's because I overruled here. Sorry, I think I'll have to delete this. I'm trying to see. Okay, I think what I should do now is to make this. I make this conserve. Go back to where we're coming from. Okay. Then I'm sleep. Okay. So I think it should run now. Okay. Yeah. Yes. Let me make this inactive here. I think I think I can now say, just like I proceeded earlier, that the inverted comma does not mean whether or not to put inverted comma. I think we should confirm now. Yeah, I think we should confirm now. I think the fact that I'm rushing is causing so much. I'm trying to see. Yeah, it does not matter. In this case, it does not matter. So I think we can put inverted comma. Where inverted comma thing matters so much is if you are writing the name of a variable that is not numeric, character variables, you need to be sure you put inverted comma so that it recognizes it as a character variable. Yes, as a character, yeah, as a character variable, yeah, or as a character, as a value, okay, attached, or as an information attached to a character variable. And when we get there, or maybe subsequently in our further engagement, we should be able to understand what this is exactly. So let's go to the next point. You can reorder your variable depending on what you want. You may want to see some set of variables first before other variables. So in this case, what we have the code here is to say, okay, inside msleep, select for first, then name second, and every other thing. Select for first, name second, and every other thing. Yeah. Okay, so your for will come first, your name comes second, then every other variable comes. So you can go on and on till you get to the last variable that you want together. Then you can now say, okay, every other thing comes afterwards, so that you'll be able to see those variables that possibly you want to do business with when you have a few. Okay, yeah, I do not want to overwrite again because of the earlier problem. So this is just, yeah, in case you want to create an object, but in case, I mean, in order for store or to prevent what happened the other time, you can give it a different name from the name that you have, the original name you have that variable represented as. And so what I've done here is that you can actually create an object from this command that you did here. Okay, and in such a way that at the end of the day, you have your msleep the exact way you want your variables to be ordered. Okay. Yeah, you want to change variable type. Change variable type. Okay, I did something. Okay, I'm hearing.
Okay, yes, please. So in this using this piping out command, it means that yes, pipe operator, yes, please. So it means that like in after running the other one that you ran and the other one you now wanted to save it as an object. So even though the other one that you ran, you didn't save it in the object, but it had finished running, that means it will still be stored in the memory, even despite it.
No, you need to, whatsoever you are doing, you need to tell R, okay, you need to tell R to save it as an object so that you'll be sure it's saved, okay, so that it is saved. But those are the commands that you need to execute to get those actions done. But for any command that you are running, in order for you to be sure that it's actually taking effect, okay, you need now make sure you possibly create it as an object. When you create it as an object, you can always view and you can be sure that that command is already effected in that data set. I think it's safer that way. I don't know if I answered that question. Hello? Hello? Hello, can you hear me?
His network is bad. He has went offline.
Network
Okay, did I answer that question? Okay, okay. All right, so now you can change your variable type here. I did something like this last week as well. Yes. You have your class, okay? This okay, so this is a function. You are interested in knowing the class to which this variable belongs. What is the class of this variable? Is it numeric? Is it factor? Is it character? You want to do that first. So it's a character here, it's a character variable. But you are interested in making it a factor variable. Okay, so you just say, you just index the 4 in your msleep and you say as factor. Okay, so okay, so for the question, the person that has the question the other time, you can see that when you glimpse your msleep, what you already did in your msleep, okay, is already affected when you glimpse your msleep now. Do you get it? Here, what you did was you give a command for msleep for, okay, for inside msleep, and you are saying you are interested in changing it from whatsoever type or class it was to factor. And so this command, this function does that for you. Then you can have a glimpse that shows you that it has actually been changed. Okay, no, you can now confirm to say, okay, sleep 4, confirm. So it's now a factor variable. Okay, so another one is you can mutate. When you mutate, you change, you do something to your variable. You change something about your particular variable. An example could be that you are renaming that particular variable. Okay, you are renaming that particular variable, or you are changing it from one type of variable to another type of variable, or you are creating another variable out of that variable, and so you are overwriting that particular the content of that particular variable, because by maybe doing some mathematical computation. For example, a particular variable may be in kilometer, you may want to convert it to meter. So what you do is you mutate. It's still that variable, but in this case, it's now in meter. And so when you mutate, you can either create an additional variable out of it, or you maintain that same name. Okay, in which case, by the time you are done with your mutation, it still retains that name. In this case, you have your sleep, and you are saying R should mutate, dply should mutate, and when it mutates, the name should be 4. And of course, you have your 4 here. Okay, and so you run. Okay. So at the end of the day, you have your class sleep 4, sleep 4. So it's factor. Okay. Right. So let's continue, please. Yeah, we have this. You want to select variables to work with. Like I said the other time, we did something like this, like this the other time. Only that this is different because we are now using pipe operator. So you are saying inside sleep, you are interested in selecting columns 2 to 4. You are interested in selecting column 2 to 4. So column 2 to 4 will mean 3 columns. So what you have selected here is genus, 4, and order. So, and that's what you have done. The next line of code says you are interested in selecting column 2 to 4, and inside that data set, you're also interested in a week. You are interested in a week. That's another column that you want to add to column 2 to 4. This is just 3 variables, column 2, 3, and 4, which gave us genus, 4, and order. But plus these 3, you are interested in adding another variable by name awake. And so you comma, then you pipe operator, you pipe it into this other command, which is glimpse. So you run. So it gives you this genus, 4, order, and awake. Okay. Under, you could also say, you are interested in variables. Okay, variable that starts with sleep to add to awake. So you could give a command. There are some variables that, okay, you have maybe the first 3 letters starting those set of variables being the same. For example, if you use a particular scale to make maybe perception scale or knowledge scale, maybe you have it numbering between 1 to 30. You do not want to start saying, writing it one after the other, the name of the variables one after the other. You just say, okay, since the variable starts with the same number of maybe the same word, maybe a prefix or something, you just say every variable that starts with sleep, you select it alongside what you have already selected, and so you run. And so what you have here is this sleep filter, sleep rem, and sleep circle. Even if you have up to 50, okay, that start with sleep, it will bring them alongside these 4 variables into the same object that you're trying to create. So that's that about that. Yeah, we have so many scenarios that we will not be able to exhaust. This is another one. You have any variable that contains WT. R has a way of also doing that. Any variable that contains WT, maybe something weight, another thing weight, another thing weight, and so you have WT being common, okay, across board. So you can do that as well. Just ensure that you are not committing, any error that may possibly have any negative effect on your analysis at the end of the day. So another thing we'll be looking at shortly is filter. We talked about filter the other time, last week. We talked about it briefly. When you filter, what you are filtering is the row. You are filtering out some rows based on a particular criteria of interest as a researcher. And so I gave an example. You may be interested in filtering out male from female, or you may be interested in filtering out. Maybe you have a data set for Nigeria. You may be interested in filtering out entries for the north central part of Nigeria. Okay, and so you specify that criteria in R, and at the end of the day, R gives you only a data frame that contains only information for the north central part of Nigeria. We ran some codes last week. I think in that direction. I don't know. I think we ran some code in that direction, but I think this one that I think possibly refreshing our memory in a way. Okay. Here you say mslip, go to mslip, then filter. What are you filtering? You are filtering by this order. Order is a variable, carnivora, or order primate. So R is bringing these two. I said this the other time. Anytime you see this mark, this sign, it's saying or. But the understanding R as of or is that it brings the two. Okay, it brings the two from that data set. So you say and this, then you select name, order, sleep total. Then you can now arrange order and sleep total by order and sleep total, and of course few. Okay, yeah, this is sufficient as a code, for example. It's sufficient as a code to run this without run this. If you run, okay, you could remove it. And maybe when you get in here, you remember when we're discussing pipe operator the other time, we said with pipe operator you use the input of an earlier statement. The input of an earlier statement becomes an output. Okay, the output of an earlier statement becomes an input of a following statement. And so in this case, you have this, and you are saying that whatsoever is run here becomes an input here. You are saying run this up to this point, then arrange whatsoever you have run. Okay, arrange by this order and sleep total. Then view. If you do not ask R to view, if you do not want to ask, if you do not want to ask R to view, you possibly come here and deactivate this part and also this part. Okay, so that's just by way of trying to emphasize what we did. I mean, remind us of what we did on pipe operator. So what you have done here is several things lumped up together, but essentially, I think the message of filtering has to also be well emphasized here. So here, what we have done here is to filter by carnivora inside this order and primates. Okay, you may also be interested in just carnivora, just like we did the other time. So your code would also end here. Okay, if you run. Yeah. Okay, what's happening? If you run. Okay. So what's happening?
There are two brackets. You need to add one extra bracket.
Thank you. Yeah, thank you. Yeah, thank you. That's nice of you. Yes. So this one normally, because we are interested in achieving beyond just filtering, and so we are bringing on board pipe operator here to index some other functions that some other statements that you want R to run as well. So I think I will need to do some yes. So sure, yeah. Okay, so okay, in this case, you are saying that yes, Peter has this by this criteria, other carnivora and other primates, and so when you see and that means you are also introducing another variable, another layer, okay, of criteria in your filtering. And so here, what you are doing essentially is to say, okay, for order, we are interested in filtering carnivora and primates, but you're also interested in sleep total that are greater than 8. And you're saying select, just like you did here, select this and arrange by this. And so at the end of the day, you run. Okay, so what you have here is all the sleep total here must be greater than 8. Okay. You can achieve that same result using this code. Okay, filter this in this. Yes. So when you have this, you are talking about in a particular variable, in a particular column, percent in percent, in a particular column. It's different from your pipe operator that you have here. In a particular column, you are saying it should look at this and this. You concatenate this, then you go on with other codes and you run. So it gives you the same result. Then you can actually arrange. I want to talk the arrange function. I think, yeah, the arrange. I think there is a data set that we looked at last week. What you want to do here is you want to arrange that data set by mass. Mass is a variable inside that, and so it will arrange in order, okay, of magnitude, in order of size. Okay, so what you have done here is to say, okay, inside Star Wars, arrange DESC mass. DESC is a function that you use to say, okay, that you use to order the from maximum from the highest to the least. So you can also do that as well. Then here you can change the content of a variable by mutating, which I have said. I think I've said before now. Yeah, this is a furtherance to what mutate does, what mutate helps us to achieve. And so here you have msleep. You can say mutate this. This is the new name that you want to achieve, and you are saying that the old variable, which is brain weight, multiplied by 1000 give you this. So and you discover that the same name you have here is what you have here. So it will definitely overwrite this. So at the end of the day, you do not have a separate variable of brain weight. You have it overwritten. And so you have, but what you are saying is whatever value is in brain weight should be multiplied by 1000, because you now want to have it. Maybe it was in kilogram before, you now have it, you want to have it as gram. Okay, so you can as well create a new variable from that. When you have it, any alteration from the old way the variable was represented, the initial way the variable was represented will mean that an additional variable, an extra variable, a new variable will be created. And that's what you will get with this command. And so you have something like this. So you can see this G. So this is G, which means okay, brain weight. Where's brain weight here? So G here multiplies brain weight by 1000. And you can see that in the data set. Okay, are we together? Are we together? I'm too fast, right? Hello, everyone. Hello.
Yes.
I hope I'm not being too fast. Actually, I have a very long script that I want to make sure I finish, and also the fact that the codes are also explanatory enough. I feel when we also get to our individual, maybe of this class, of this synchronous session, when we get to our laptops on our own, we can run the codes, and many of these things I'm speaking to, I'm very sure we'll be able to get them. So the code is a bit long. Just my sincere apologies, and I want to ensure that we do not exceed the time. And so that's that about that. Let me remove this, because I already wrote here that you want to overwrite or recode to the same variable. So let me run it again. Okay. So you do not have your G any longer, but you have your I think your brain weight now changing from what it was to this after it has been multiplied by, each of the values has been multiplied by 1000. Yeah, this is like the function that you use, the code you use to create a different variable. Okay, you recode to a different variable. So in this case, you have the new variable now in grams. When But you are saying this new variable that is tagged brain weight in grams should be from this old variable. And what computation are you trying to do to have this new variable created? You are saying the new values should be multiplied by 1000. Just what we did here. But in this case, the only difference here is you are naming it differently. And so you, at the end of the day, you end up having the two names in that data set. And so you have this as the new, and you have this as the old. Okay. Now, here you have the conditional changes. You are here interested in, yes, your data meeting some certain conditions. Okay, so you are interested in using that condition to now say, okay, you belong here if you meet this condition, otherwise you belong here. That is what this part talks about. For example, you may have a score ranging between 1 and 100, and you want to use a particular benchmark to determine who fails and who does not fail or who passes. And so at the end of the day, you say, okay, you could say, okay, benchmark is 40. If you pass, if you have 40, you pass. If you have anything less than 40, you have failed. And so you want to just possibly create a variable of pass and failure or pass and fail, okay, using that that criteria. And so what you do, what you use is you also mutate, but plus your mutation, you use a particular function that is called if s. So you are saying if it is this, let it be this. Otherwise, let it be this. Okay, if it is this, let it be this. S, then let it be this. So that's what if s function means. And so you are interested in brain weight. Okay. And you are saying, okay, you are running a query to say, okay, let's see if we have values that are greater than this value in our brain weight. And so that was what we ran. And it's saying, yes, there are some that are NAs that's missing, and there are some that are true, that is, that are actually greater than 0.01. And so you are saying you are interested now in creating an object size of brain, and you are saying R should go into sleep, then select name brain weight, and drop NAs because you have NA here. You drop NA in brain weight, then this function and NA dot omit is the same thing. Now, then you say your pipe operator again. That's you pipe it into mutate brain size. Brain size. This is what you now have as your new variable. If S, that is, if the value in this brain weight, if it's greater than 0.01, let it be large brain size. Otherwise, that brain is small. Okay, you are saying if S, this if S is a function, and you are saying the way the argument is that anything inside the bracket is that variable. Okay, you are saying in that variable, any value that is greater than 0.01 is large for that brain, and anything otherwise, S. And so you run. Okay, I say size of brain. Okay, you can see now size of brain or brain size here has changed. I mean, it assumes this, and it's a creation. This brain size as a new variable is a creation from this, which is what mutate function has helped to achieve. This code is not so so strange. I think we did something like this last week. You want to now recode your large and your small into 2 and 1, or in some cases you may want to say 1 and 0. And so you use this same mutate, and you combine it with your code, which is also a function, and you say brain size, comma, large is equal to 2, and small is equal to 1. Okay. Do we have any question? Okay, anybody with any question, please? Should I continue?
Sir,
Okay.
if you hadn't saved this mutation to the object size of brain, I think, would it still have been saved in that initial data sets without you saving it as an object?
Okay, the same. Okay, I think it was the same person that asked the question the other time, right? So let's
Yes,
check.
I was hooked up by my network.
Let's check now. I've piped it in now. and I'm saying view. Okay, let's check. You can see. You can see that it's changed now. Do you get it? So it will still change in that, because what you are saying is, you are saying go into, okay, so where did that, okay, you are saying go into size of brain, and inside it, do this, perform this function. After you must have performed that function, then I want to view. Do you get it? So it's as good as you are saying, let's say, okay, let's say size, okay, let's check now. Size of brain. Size of brain. What's happening here? Sorry, size of brain. Okay. If you show valid caption, okay. Where is size of brain coming from? The size of brain. Okay. So why will it not show here? It's the same. Okay. Let me, sorry. Size of brain. Default method not implemented for type first. What's happening? It's supposed to show. That's one interesting thing about her. Sometimes you make a lot of mistakes, then you figure it out later. So, but then it helps. The whole thing helps you to internalize.
Okay, I think it's because there is the piping operator in the previous line.
Okay.
So it sees it as continuous. I think.
Here. Aha. Thank you. Okay, this is what you meant, right? Okay. Let's see.
Yes, sir.
Let's see. Let's run this now. Okay. Yes, size of brain. Thank you. Okay, so obviously it did not change. I think that's it did not change. I'm trying to see why it did not change. Let's run it. So that means if you want it to reflect, okay, you have to create an object. You get it now? Hello, my friend. I asked that question. So if you want it safe, I think that was my earlier position. I was just trying to confirm here. If you want it to change, if you want it to save, okay, into an object, if you want it to reflect, you have to overwrite, okay, the earlier name, so that whatsoever you are doing, you are sure is actually affected in that particular object that you are interested in at the end of the day. For example, these are just procedures. But if you want it to reflect as you are moving from one step to the other, you do not want to just continue. You want to also create an object here and say, okay, size of brain. Okay, size of brain of brain, two of them. So you can say, okay. So at the end of the day, you can be sure it will now be inside this now. Okay, as against when you were just running and you were not really indexing it into a particular object. So I think that's a very good question that led us to doing this, to do the confirmation. Yeah, thank you. So okay, I think this about the last part. It's about the last part. Just give me like 5 minutes. I think I should be done in 5 minutes. Yes, this place is yeah, this code is for you to create some categories from a numeric variable. You deal with some numeric variables and you do not want to present, yeah, without processing into some categories that of course can make meaning to whosoever is reading your work or your report, as the case may be. For example, you have age that ranges between 10 and maybe 60. You do not want to present a list, okay, in your report. You want to break it. You want to come up with categories based on a particular criteria that you may have used to do that. And so this is an example here. You have your mslip data, and you're saying you are mutating. You still use your mutate function, and so you do this. Then you say this case when brain white is less than or equal to 1, you name it 0 to 1. Okay, brain white is greater than 1. Okay, and it's less than or equal to 2. You name it 1 to 2. Brain white rep. Okay, when brain white rep is greater than 2, but it's less than or equal to 3, you name it 2 to 3. So at the end of the day, you come up with how many categories? 1, 2, 3, 4, 5 categories. And so at the end of the day, you yes, you create the level. You say level is concatenation of this, this, and so you have a glimpse. So at the end of the day, you have something like this. Okay. So I don't want us to waste time here. I'll sort it out and give us the correct code. I think something went from somewhere.
I think it's because you didn't put a pipe operator after the end of line 154.
154. Okay.
At the end of that line.
No, I'm not supposed to put pipe operator here. You remember where I'm coming from? This is where I'm coming from. Assuming I started like this, that's when I will need a pipe operator here and maybe another command here. But if I have started by creating an object here, then I do not need a pipe operator here. I'm just supposed to close my script. I mean my code here.
Command, yes.
Yeah, you get what I'm saying? Yes. So I think I will figure that part out, and of course get back to us. Yeah, this part, this part is another very interesting part. You have your data as long. You want to convert it to wide, or you have it as wide. You want to convert it to long. It's very important. I mean, this part is a very important part. For example, there are some analysis you want to run. If they are in wide format, it cannot run. Okay. For example, you want to run an ANOVA, and you want to have your variables are in wide format. It will be difficult for you to run an ANOVA that way if you don't make it long. Because, for example, you want to have a factor variable, okay, that has different levels down. Okay, then you want to have your values, I mean your figures that you possibly compute the mean for in such a way that you can at the end of the day have your ANOVA run and well interpreted. I mean run well in the first instance at least. So what you do there, okay, let's look at this data set. You have the Gapminder, that's the data set. Let's view it. Is the Gapminder. So this data set is in long format. Okay, you have the year, you have the life expectancy, and you have the country. So we are interested in making it wide, in which case, instead of having our year long like this, we can have our year here. And in which case, we'll be having all these years, taken to different columns. And so you now have your values to the years, okay, spread across different cells under the years. And so what you are saying here is you are saying, okay, you are interested in reshaping that data set from that orientation, that long orientation to wide. And so you use pivot wider. And so under pivot wider, what you do is you say, okay, wide data. Remember, we're coming from data. So you are saying instead of it in long, the way it was, you want it wide. So you are creating an object, wide data, and you're saying wide data is from data. So take your data and pipe it into this command, into this statement. And so pivot wider names from year. Okay, you want the names that will appear on the columns to come from the years. And you want the values to come from the life expectancy. And so you have it in view now. So you have it like this. Okay, if you want to draw maybe a line graph now, okay, you want to draw, or you want to you may want to, what do you want to do with this? You want to compare across the years, okay, for different countries. Okay, you may, this may be fine, but if you are interested in running an ANOVA, let's say you're interested in running an ANOVA of okay, what do we have here before now? Let's look at the code again so that to follow. Name of year and value. Okay, names of year. Okay, names of year. Names from year. Okay, the years. Okay, you want to compare across the years. Okay, for example, you want to compare the life expectancy across the years. This may not serve the purpose, because you possibly will want to run an ANOVA, okay, because you are interested in comparing the means across the years. And so this will not suit that purpose. You would possibly want to have your data set reshaped to long, which it was originally. But there are some scenarios of analysis that will also require that you make your data assume this dimension of wide. So if you have your data available in wide format, you can also take it to long. So you can take it from that format of wide back to long using pivot longer. So the same way, it has taken it back to this point. So if you're interested in, for example, comparing life expectancy across the years using possibly an ANOVA, in which case you want to make this like a factor level variable, you can easily do that using this kind of data set orientation. Yeah, the remaining ones are well self-explanatory. This is just to, and interestingly, I've done something in this regard before now. You have this data frame then that has gender and height, or DF, and you want to split the data frame by gender, male and female. You say split DF, which is your data set, and this is your variable. And so you want to say, okay, so this is for female, and I think the one for, okay, yeah, this is for female. You can also do the one for male. Okay, you want to summarize the height for male alone, so you run this. You want to do that for female alone, you run this. You want to do for everything in the data set, you run this. And you want to summary for, okay, I think I've done that earlier. So that's that about that. And you want to run, you want to, for all variables, you want to create a summary for all variables. So you want to create a summary for all variables, but you are using this factor, this categorical variable. I've moved from this other this other data set now to this. So you want to use this factor, this categorical variable. Okay, you want to split the summary by this categorical variable. So just run your, you have a glimpse. Then you run together like this. Okay, it's running. Okay, all right, yeah. So this is the 4. The 4 is you have different categories now here. You have under 4, you have AB4, you have I think you have carnivore, you have insecty, yeah, you have another one down, omni. Okay, so what it will do is it will split the summary by this categorical variable instead of doing the summary overall. All right, I think thank you very much.